Welcome, everybody. Here is our final project for P8105. We basically use regression analysis to study the multiple factors and bioindicators of type 2 diabetes. So at the homepage, we introduce our motivation and we put some important parts from our exploratory data analysis and statistical analysis. And first, let's move to our Shiny app. So here we develop an innovative Shiny platform to enhance user interaction with our diabetes dataset. User can select from a comprehensive array of X variables, for example, high blood pressure, high cholesterol level, BMI, etc. Upon selection, the platform will just dynamically generate and display a histogram illustrating the association between chosen X variables and the Y variables, like this. We can play around with different X variables and see the association between the X and the Y. So let's move on to the second part, which is the EDA.
After we finished our data cleaning by formatting data types and cleaning variable names, we're ready to move into our EDA part. So our first step is to generate our diabetes distribution to visualize the number of the whole sample diabetes status. And as you can see, right here, the pre-diabetes group sample is too small, so we decided to drop this group, and our further analysis will just focus on no diabetes and diabetes. The second step is to generate the distributions of different factors into diabetes status by using ggplot, geom-bar, along with some formatting functions. So we generate 13 potential factors across the diabetes status. The visualization allows us to shrink our attention on only 9 variables that are most significant, approachable, and logically make sense. They are blood pressure, cholesterol level, BMI value, sex, income level, smoking status, fruits consumption, veggies consumption, and physical activity. So we can combine the 9 plots together for more explicit visualization. And our third step is to further investigate the specific variables like the only numerical variable BMI with box plot. So you can see diabetes group has generally a higher median BMI value than the non-diabetes group. And then we make a mosaic plot for veggies and fruits consumption frequencies. Since we assume these two variables may have some association, the next step, we generate an R table one to see some factors frequency and p-value to test their significance. And as you can see, all of them have a p-value smaller than 0.001, which enables us to do further statistical tests. Our final step is to generate a heat map to visualize the intercorrelation between each variables. The map shows that green boxes means they have some correlation and the pink boxes don't. We only have variables like income and education has a correlation around 0.5, and there's another group of variables like difficulty to work, general health, and physical health has a correlation of 0.4, which is good, as our non-variables are not affected by that. These are basically our EDA part. So let's move forward to our statistical analysis.
Now I'm introducing statistical analysis. We mainly doing feature selection in this part. First, we plot correlation analysis with 9 variables selected after EDA. And we did ANOVA test. We find only fruits have slightly insignificant p-value. We also did chi-square test and find all variables have significant p-values. So we move to predictive model building. We try to fit with logistic regression model. In the trend dataset, we can find that fruits has 0.4 p-value, which is very insignificant. So we do the backward stepwise to drop fruits variable. Also, we did model validation by using test data, and we can find that there is 85.89% accuracy, which shows that our regression model performs pretty well.
Now let's move to our report part, which is in the upper right corner of our website. We have basically everything in our report, including data cleaning, EDA, stats tasks, and also model building part and Shiny part. So we'll quickly go over the result and the discussion. Our findings suggest that to prevent diabetes, we should focus on maintaining healthy blood pressure and cholesterol levels, avoiding harmful habits like smoking, and promoting physical activities. In conclusion, our research highlights the complexity of diabetes and the need for a holistic approach to prevention and management, combining healthcare intervention with lifestyle and social support. This comprehensive strategy is vital for making progress against the diabetes epidemic and improving public health. Thank you for listening.